Okay, so we're just looking at excuse me, conditional probability, which is just a loose ends are left off. So in some questions in probability, we're not concerned with all the outcomes, we're just concerned with some of the outcomes, and these are the conditions that can be put on a question. Okay, so let's have a look at a question. If you throw a die, there are normally 6 outcomes, 1, 2, 3, 4, 5, 6, which I've shown in the tree diagram. What is the probability that if you throw a die and it's an even number, it's also divisible by 3? Okay, so what's the probability that a number is even, so a number is divisible by 3 given that you start with an even number? So for instance, there's 3 even numbers, 2, 4, 6, and only one of them is divisible by 3. So of these 3 answers, one of them is the right answer. So instead of having a different answer, it's just the condition condition that restricts the outcomes to 2, 4, 6, and the answer is 1/3. Okay, so let's have a look at the next page. So there's a formula that can be used to calculate conditional probabilities, and what we have is this stroke probability of A given B. So this stroke here means given. Okay, it's not a fraction line. So the probability that what's the probability A given B happens? And the answer is the intersection between those two events divided by the probability of B. So in the previous example, probability of A divisible by 3 is a 3 and a 6. B, we had to have an even number. So the outcomes so the intersection is when those two things happen at the same time. So those two things happen at the same time. So there's one thing that happens, and B had 3 things, so the answer is 1/3. Okay, copy that and come across. Okay, so again, we're just listing the outcomes as a way of doing it. So 2 dice to toss. What is the probability that the sum of the numbers exceeds 10, given that you get a 5 on the first toss? So the event A is the numbers exceed 10. So a 5 and a 6, a 6 and a 5, and a 6 and a 6. They're the outcomes of exceeding 10. And given event B, that there's a toss of 5 on the first toss. So there's only one outcome that occurs in both sets. So there's one thing that happens out of 6 things. Okay. Let's have a look at the next example. Okay, Mary and Tim are a married couple, aged 30 now. Their respective probabilities of being alive in 40 years' time are 0.8 and 0.7. What is the probability that Mary is still alive in 40 years, given that only one of them is still alive? So showing you in a tree diagram what's happening, and then we'll try to do it with the formula as well. Okay, so here's Mary alive, and here's Mary's dead. Tim's alive, Tim's dead, Tim's alive, Tim's dead. So MT, Mary alive and Tim are alive, multiply 0.8 by 0.7, you get 0.56. Mary alive, Tim is dead, 0.8 by 0.3 is 0.24. Mary is dead and Tim alive is 0.14, which is 2 by 7. And both of them are dead is 2.2 by 0.3 is 0.06. And so those numbers add up to your 1.0. So in this particular question, what's the probability that Mary's alive given that these are the only 2 things that can happen? Okay, so the other outcomes don't happen because the question says that only one of them's alive. So Mary's alive 0.24 divided by the 2 things that are happening, which is 0.38. Okay, and then just move the decimal places 2 places and you get 24 over 38, which is 12 over 19. Okay. In terms of the Bayes theorem, okay, so we're looking at the intersection between A and B is Mary is alive and there's only one person alive, which is the 0.24. So Mary's alive and she's the only one alive, and the probability of B is one person's alive, which are those 2 events. Okay. Let's move across to the next question. Okay, so here's a question, and there's no numbers, no description, no words per se. So we've got probability of A, probability of B, probability of A intersection B, and we've got to find the union, and then A given B and B given A. Now, just in case it didn't come up in any of the earlier questions, this is a fundamental question, a fundamental theorem. The probability of A or B is A plus B minus the intersection, or the intersection equals A plus B minus the union. Okay, so if you had a Venn diagram, and you had A and B, if you want this first one, if you want A or B, you add A, you add B, and then you subtract the overlap, okay, because you're counting it twice. So this one here applies with Venn diagrams. If you want A or B, you add A, you add B, and you subtract the double up, which is in the middle. And then to get the second formula, that and that can change spots, okay, just by moving them to other sides. So in this particular one, if I want A union B, I have A plus B minus the intersection, so A plus B minus the intersection, which is 0.8. And then once I've got that, A given B or B given A is just the formulas. So A given B is the intersection over the second letter B, or B given A is the intersection over the second letter, which is A, and you end up with those answers there. Okay, and there's a worksheet on Moodle, so hopefully you'll enjoy that. Thanks for coming.